Hello. Today we are going to discuss about how to generate OOP class diagrams using LLM tools. Now, as you know, we create different sort of diagrams when we are developing software. These diagrams will help us to understand the project properly, or when in case we need to do developments with the multiple teams, it is easy to communicate what the requirements to the teams. And if we need to do any modifications in future, these documents diagrams will help us to uh, do our software development much efficiently. So today what we are going to do is we are going to develop we are going to do a OOP class diagrams. We are going to draw OOP class diagrams using requirements, using functional requirements. As you know, functional requirements give us high-level understanding to the software project. Not only functional requirements, use case diagrams, user stories will elaborate the project more detailed than functional requirements. So what we are going to do today is, using basic functional requirements, we are going to generate OOP classes. So two important points before we start anything. Number one, your requirements should be accurate and fully completed. If not, if you have inaccurate requirements, or if you have half requirements, you will not be able to generate OOP class diagrams with this method. As I said before, requirements give you the basic high level view to your projects. So if you want to develop a better class diagrams, it is always better to use user stories and use case diagrams than functional requirements. This using functional requirements, you can develop OOP classes, but using use case diagrams, you can do a better job than this. Okay, let's assume these are our basic functional requirements for a customer order entry system. I believe you all have experience with the customer order entry system. So these are the basic requirements. We have the customer, we have the product, we have the cashier, and then we create the orders, and then we go to the payments, and then we have the shipping and delivery, and then we have the three reports are listed here. So you can see we have quite a set of functional requirements in this simple order entry system. So what we are going to do now is, using these requirements, we are going to create OOP class diagram, object-oriented programming class diagram. Right, so let me copy this first. And then I am going to use Gemini. I'm going to use Gemini for this. So I'm saying generate PlantUML OOP PlantUML code for OOP class diagram. Now, what is PlantUML? So that is the web service that we can generate class diagrams. Now I can do this, but it's always better when you are using prompts, you provide more details. I can say for order management system. Correct that. So it is very important to mention OP class diagrams. If you simply say class diagrams, you will never know what it will generate. Or if you just say diagrams, it might generate ER diagrams, it might generate activity diagrams, so you're not sure. So it has to be very specific and to say that it's a class diagram. Right, so it generates. So you can see the class diagrams, classes are generated. So you can see the customer class. In a class, you will have the properties, and these are the methods. And also for the product class, you have the product and a cashier. So let's copy this. Let's copy this and paste it into plant UML window. So it's a plantuml.com, and then I will generate. I will generate this. So you can see class diagrams. The properties are there, methods are there, and there are relationships to those between classes. So basically, we can get a basic class diagram. Remember, basic class diagram, not the detailed one. Second important thing is verify whether you have all the classes. So seems like we all have the correct, we have got the correct details, but do you think there can be improvements? Now, for example, you can see customer and cashier. Customer and cashier both can be derived from a person class. So shall we write down what are the improvements that we can do? Right, number one, person class to be introduced. Cashier and, I'm writing it in a short format, cashier and customer should be inherited. That's number one. What else we can do? Now you need to look, now you need to think from your OP principles perspective. Right. So one is done. And if you look at the products, so you can see products are there, but we can create a constructor. You know, when we are creating an object from a one class, there is a default constructor where you will not have any properties will be filled. So what we can do is, we can say, okay, we want to create a product constructor for the code parameter. So we can say second change that we are going to do, product class should have a constructor with for code, for code. So I think, yeah, we have a code. So we can say we can have a product code constructor, code for construct. Right. Let's move. Now, when you have payments, as you know, payments are done by multiple ways: cash, credit, and check payments. So we can say payment is an interface. Payment is an interface, and three payment method: cash, check, and credit cards are should be implement from payment interface. So we are saying credit, cash, payment should be an interface, and then we can say credit cards, cash, and check payments should be, no, we don't say extend, because extend is we use for when we inherit the classes. So for the interfaces, we say implement should be implemented from the payment interface. Next one, we can see reports. So reports, you can see, is a basic reporting that they have introduced, but we can go for details. Now, every report, you have the header and the footer, which is generic. So what we can do is, we can create a report abstract class to create header and the necessary parameters and the footer. So we can say create a report abstract class that includes getting the parameters, that includes, let's say, methods for getting the parameters, report header includes report name, print date and time, and report footer. And then we can say introduce 3 new classes, because we can't have one class for all reports. It has to be 3 separate classes. Introduce 3 new classes for each report that should be inherited from the report abstract class. Right. 6th one is encapsulation. One of the important thing in object-oriented programming. We can say introduce encapsulation for all the classes, introduce set and get method for all class variables. So you can see how you can improve your class diagrams rather than simply accepting what it generates. So now what I'm going to do is, I'm going to go back to the Gemini and I will ask improve my plant UML by using these comments. So now it generates new set of plant UML, Let's go and verify. Let's go and verify. Submit this. Right, now you can see person class. Right, so let me check those things. Let me think we can get it into, okay. Right. So we can see number one, we can see let's go one by one with the, what we have said. Introduce a person, cashier and customer to be inherited. Yes. Yes, those can be seen here. Person class is introduced, and with the cashier and customer is derived from the person class. Then product should have a constructor. Let's go and verify whether the product has a constructor. Yes, product has a constructor. You can see that product has a constructor with the code variable. And payment should be an interface. Yeah, it's an interface now. Normally, standard these interfaces are your naming convention. You start with an I. So you can see the payment interface, and then it has the basic two methods: validate detail, generate receipt. And so the credit card payments will have those methods, concrete methods in the implemented classes. So that is also done. Then report abstract class. Let's go to that and see. Okay, you can see the report abstract report class is also generated. And then you have the three separate classes for each report. Yeah, so that is also done. Encapsulation, you can see all we have the get and set methods for all variables. So you can see by using PlantUML and LLM tool, Gemini for in this case, we have created a very detailed class diagram. So remember, very important thing is, once it is generated, still you have to verify this. You have to verify this. There can be errors. There can be issues. Sometimes your requirements might not be correct. You have half-cooked requirements. So in that type of a situation, it is very important to verify whether this has covered all the requirements that you need. Number one. Number two, if you have use case diagrams or user stories, you can do a better work than this. So just to indicate you the differences, what are these class diagrams, or what are these requirements, use case and user stories? You can see use requirements. What we use today is a broad and formal description of the system function. It's a broad. But if you go to user story, it's a high level description of a features from user's perspective, focusing on values. Use cases will have detailed narrative of a use case. So you can see there are differences between these documents. So what I use today is a requirement document, which is basically used by the BAs between the client and the dev teams. But for dev teams, it is better if you can have the use case diagrams and the user stories to generate this OOP diagram. But important thing here is you need to verify your results. Number one, you need to check whether you have got the correct results, and your relevant documents, requirement, use case, and use stories are correct. If not, don't use this method. Go back to the drawing boards and draw it from yourself. If you have good detailed requirements, then only this method will be helpful. Thank you very much. Hope you have understood how we can generate OOP class diagrams using tools.